Okie doke, so we need some theory, and I'm going to take you through a couple of the older theory papers before we get to the main theory that I really want you to get your heads around. Let's see, and we're going to start with the classic paper by Nancy Stokey from 1998. So, against this background, how are we to understand the observed patterns? There's still no widely accepted theoretical explanation. One reason for this is that researchers building theoretical models have fallen into the trap of treating pollution as an input to production rather than as a byproduct of the use of natural resources. And that trap goes back, the tradition of thinking that way goes back at least as far as Baumol and Oates' textbook. Okay, if we think of pollution as an input in a Cobb-Douglas production function, then we know that the factor share of pollution must be constant. We'll look at this. We've already looked at this I haven't really talked about it that much. We'll talk about it in a second. And if we let the marginal damage caused by pollution track income, and we assume optimal policies, so the price of polluting tracks income, goes up with technological progress, then the flow of pollution should be constant as the economy grows. Okay, I don't know if you can get your head around that, but I'm now going to do the math. So assume y equals ALL to the 1 minus alpha, z to the alpha. So we've got the Cobb-Douglas production function, z is an input. And u is y times 1 minus z, where u is instantaneous utility. AL grows, whereas L is constant. What happens? Okay, we're going to look at that. I'm going to go through the math. So just let me pause. Okay. So we've got y equals ALL to the 1 minus alpha z to the alpha, and we've got u is y times 1 minus z, and we're going to assume optimal policy. So du by dz is minus y. So the effect on utility of emissions are directly proportional to y, right? So the price of emitting WZ is gonna track growth, okay? Right. Next thing. So y is ALL to the 1 minus alpha, z to the alpha. How much pollution do we choose to emit? So the profit maximizing representative producer, his profits are PYY, whereas PY is normalized to 1, minus WLL minus WZZ. And remember, I haven't talked much about this, but we assume always, unless we say anything else, this is perfect market. So this is a small producer who's representative of all the producers. So this producer is a price taker here. So WL and WZ are exogenous to that producer. So then when we take the first order condition in Z, we get dy dz, which is alpha y over z equals WZ. Or WZ, Z is alpha Y. And this is the constant factor share. The factor share of pollution is what the representative producer spends on polluting inputs, and that is a constant share alpha of total production Y, and that's the share. The equivalent result for labor would of course be 1 minus alpha Y is WLL. Okay. Now if we set WZ equal to Y, then we're going to get that Z is alpha. So if WZ grows with GDP, the polluting inputs will just be constant at alpha. So that's under optimal policy if we tax pollution. So this isn't great for the EKC, is it? Because this is saying pollution should be constant as the economy grows, not that it should go from a low level up and then down again. So how do we get that result? Oh, sorry, I'm off the page. How do we get that result? So let's see what Stokey does. Okay, so what happens under optimal policy? Pollution is constant. Whoops. So this is like our DHSS style model with land, in which the price of land tracks the growth rate. But here it's the price of pollution which is tied to the growth rate, and this leads endogenously to a constant flow of pollution. So what does Stokey do? So before we go into that, let's just draw a picture. Sorry, I'm going to pause again. Okay, so before we get into that, we're going to draw a picture. This, oops, sorry, I need to sort my screen out again. Okie doke. So we're going to draw this picture, and what have we got? We've got pollution on this axis, and production on this axis. Oh, sorry, yeah, Y it should be. Yeah, right, Y. And what we just showed was if we just have the straightforward production function, Y is ALL to the 1 minus alpha, Z to the alpha, then oh, sorry, this should be Z. Yeah, pollution Z. Then if pollution's 0, there's no production, right? And then as pollution increases, production increases, but at a decreasing rate. And if ALL had happened to be lower, it would look like this. If ALL were higher, it would look like this, and so on. Okay. So I'm going to pause again. Okay, I paused because I realized my first picture wasn't great, so I scrubbed that and I've redrawn it like this. Now, what our calculations just showed us was, if we just had Y as ALL to the 1 minus alpha, Z to the alpha, we would always choose the same amount of pollution, alpha, in the optimal, if pollution was optimally priced. Okay, so as ALL increases, here ALL is low, Y is low, but polluting emissions are alpha, ALL doubles, Y doubles, pollution emissions stay at alpha, and so on. Okay, but then Stokey said, what if y is actually the minimum of ALL to the 1 minus alpha, z to the alpha, and ALL? So what this is basically doing is saying that polluting emissions will help you up to a point, but for any given level of productivity, there's a maximum level of pollution beyond which polluting even more doesn't help. Okay, and that maximum level of pollution grows with productivity. And that's what this dotted line is about, because that is where this curve crosses the dotted line. That's the maximum. So when productivity is low, polluting more than this doesn't boost your production. So here you're like full on polluting. Okay, when your productivity is a bit higher, polluting up to here boosts your production, but beyond that it doesn't help. So you can't produce more than this here and more than that here, even though this line keeps going. Okay, what happens now? Okay, so if we start here, the maximum level of pollution is less than the level that you would expect given the price of pollution. So it basically means that we're at a corner solution, we pollute this much. And if we drew another curve for even lower AL, you would be here. Basically, as ALL rises from 0, you're going to move, pollution is going to move along this line, increasing in line with GDP. But then when we hit this point, pollution has reached alpha. Now, if we could, sorry, let me just pause again. Yeah, so now on this line, more pollution would give more production, but it's not worth it. Given the price of pollution, it's not worth polluting that much. The cost is too great. We've hit this z equals alpha line, so we go here. So basically along here we're at a corner solution where we pollute. Even though there is a pollution tax, the producers pollute at the corner. They don't abate. Stokey phrases it in terms of abatement. So here they don't abate at all. They pollute at the corner to maximize their production, but at some point the tax gets high enough that instead of doing that, they sacrifice some production and abate some pollution. So this gap is the amount of pollution that they abate. Okay, right.